Figure 1 shows this curve f of x, and we are asked to work out the points P, Q, and R. Well, we sort of have a difference of two squares here. It's going to be root 12 minus x, and then root 12 plus x. And if you set that equal to 0, you see that x is going to be 0, hence why it goes through the origin, and then x is root 12, or minus root 12. So that immediately gives us that P has coordinate minus root 12, 0, and R is root 12, 0. That leaves finding Q, and for this we need to differentiate. So f of x is going to be 12x minus x cubed. So f dash x is 12 minus 3x squared. And this is equal to 0 for stationary points. Sorry, I just couldn't quite fit it in. Divide through by 3, so 4 minus x squared equals 0, and that's going to give me x equals plus or minus 2. Now I can see from the graph that this one's going to correspond with minus 2, and q is going to correspond with 2. So when x equals 2, f of x will equal, now we don't need to substitute it into this one, it's actually going to be better to substitute it into the first one. It's going to be 2 times 12 minus 4, which is going to be 16. And hence finally we also get that q is 2, 16. Next up, we are asked to sketch some related functions and also indicate maximum, point, and the intersections with the x-axis. All right. So the first one is going to be a stretch by factor 1/2 in the x direction. So it's going to look very similar. And we've still got the origin here. Do I need to indicate that? All right, I will. And before we had root 12, so I need to do root 12 and divide that by 2, which is going to be root 12 divided by root 4, which is going to be root 3. So this point here is going to be root 3, 0. And therefore this one is going to be minus root 3, 0. That just leaves us with the other coordinate, which was 2, 16. So the stretch is just in the x direction. Therefore, we divide 2 by 2 to give 1. The y coordinate will still be 16. So that is our graph, y equals f of 2x. Now let's take a look at the second one. This is a lot more complex. So first things first, I'm just going to draw a little mini sketch of y equals f of the modulus of x. So the for positive x, it's just going to look exactly the same. It's going to come up and down like that. Now, if x was minus 2, then you would get f of 2. So actually, it's going to be perfectly symmetrical. And we lose this part. And it's not the same as finding the modulus of the left-hand side because it does go negative here. So now, here's the main bit. We want y equals f of the modulus of x plus 1. Now, if x is positive again, then it's just going to be f of x. I might write that down actually. If x is greater than 0, this becomes y equals f of x plus 1. And this is a translation by minus 1 in the x direction. So basically this is going to move to the left up to the point where it's positive, and that means it's going to look like this. So it's like it's moved, it's gone up and it's carrying on up and it's coming down. And we can look at what the points will be. So this point was root 12. It's now going to be root 12 minus 1. And this point was 216. Now it's going to be 116. Okay, I'll focus on that point in a minute. Now, if x is negative, then basically we just get the same thing. It's again going to be a reflection in the y-axis. So it's not actually moving to, this one's not moving to the left. This one will mirror it. Look a bit like that. So here, it will be basically the negative of this. It will be 1 minus root 12, 0. And this will be minus 116. That just leaves this final point. Let's just look at the original function, which was x 12 minus x squared. Oops. Okay, I didn't kind of regret writing that down, but when x is 0, this is what I'm interested in. We get f of 1. And actually, I could have just put this into the original function. That would have been a lot easier. So it's going to be 1 times 12 minus 1. It's going to be 11. So this point here is going to be 0, 11. Really interesting how the modulus just changes functions. A good question, I think. We have one more part to do in this question, and we're considering this function here. Now, I've got to admit, when I did this question myself, I had about 2 pages of working. I wrote down the function in terms of x, v, and w and started differentiating it and things like that. But there's a much quicker way, so that's the way I'm going to show you. Because if we write down y is equal to f of x minus v plus w, we can see that we've got the original function, and then we've translated by v in the x direction and w in the y direction. So if we look at the points that we had before and relate them, we can get some of them. So we had the maximum was 2, 16. It's going to move to 2 plus v, 16 plus w. And then this point here, well, we didn't talk about it, but actually, I'm going to do this in blue, sorry. This curve is anti-symmetric about the y-axis. It's basically, it looks the same, it's just negative over here. And it must be that this is minus 2, minus 16. I mean, we actually found a stationary point here, it was minus 2, and we would get minus 16 if you substituted it in. Now, what that means is that if we consider it over here, it's going to be minus 2 plus v, and then minus 16 plus w. However, in this case, we're told that it intersects the y-axis, or it just touches, so it's also equal to 0. And that gives us our w straight away. W must equal 16. Now, to find out what v is equal to, let's consider s. By the way, we now know that this is equal to 32. So we have the point 0, 32 for s. So when x is equal to 0, we can substitute that in, and we're going to get that f of minus v plus 16 is equal to 32. And the original function was x times 12 minus x squared, so it's going to be minus v, 12 minus v squared. This will equal 16, and I can rearrange that to v cubed minus 12v minus 16 equals 0. Now, there's 2 options. You can either substitute numbers in to try and make this equal to 0, and then you'll get a factor, or you can actually look over here, and if v was equal to minus 2, then we would get that the function was equal to 32, and this would actually be over there. So that is going to be one possibility route to this equation, and in fact, it's going to be a double route because it comes up and then goes back down. If you're not happy with that, then understand, but that is possible. So I'm kind of running out of room here, but I'm gonna keep going. V plus 2 is a double root. And again, I'm just going to say it one more time. If v was equal to minus 2, you'd get 0 here, and it would clearly be when x is 0. That would work out. So we can write v plus 2 squared, and this would give plus 4, so it must be v minus 4 equals 0. We don't need to do polynomial division because we can just look for the coefficient. Of course, if you want to check it and just check it definitely works, yes, you have to multiply it out, or you could do polynomial division. But overall, we're going to get that v is equal to 4. remember, v is actually, just by looking at the graph, we can see that v is positive because it's moved to the right. So it can't actually be -2, and because this isn't actually there. Ignore v equals -2. Therefore, we're trying to find the roots of this equation, x minus f of x minus 4 plus 16 equals 0. Now, we already have a root, actually, and it's over here. And it's going to be when v is 4, so it's going to be when x is equal to 2. So that's really good. And in fact, that will be a double root. So x minus 2 squared will be a factor. Okay, I'm going to take this and I'm going to have to go to the bottom of the page now. This is useful as well. So if I substitute x minus 4 into the original function, then it's going to be x minus 4, and then it was 12 minus x squared, so it's 12 minus x minus 4 all squared, and that is going to plus 16, that's going to equal 0. So I'm going to need to expand this out. I'm going to get minus 8x, it'll become plus 8x. I'm going to get plus 16, that's going to be minus 16. The 12 and the minus 16 will become minus 4. That's going to leave me minus x cubed plus 8x squared minus 4x plus 4x squared minus 32x plus 16 equals 0. Okay, just swap all the signs around. Now, as I said before, all the way back here, we already have one of the roots, and that is when x is equal to 2. It would be a double root. We just need to find this one here. That's the only one remaining, and therefore we can just write this as x minus 2 all squared. And the only thing that will work, because I've got a plus 4 to get the minus 32, it's got to be a plus 8 here. Like I said before, you can do polynomial division if you want. You might want to multiply this out to check that it does actually equal this, because it is very easy to make mistakes in these questions. But we're going to get the x. And actually, I have made a mistake, haven't I? Because I had 4, that should have been minus 8, sorry. 4 times minus 8 gives minus 32. And therefore x is equal to 8. So overall, the roots are 2 and 8. I already had the 2 on, but we should probably write it down like that. Now, I just noticed, just finally, we've done the question, but there was a quick way to get that 8. And it was to look at this curve and see that we've got here, I've got x is 0. In line with this, I've got 2. In line with this, I'm going to have 6. So if you kind of look at the symmetry and seeing to go from here to here, sorry, it's actually like these are kind of symmetrical in some ways. So basically this distance here must be the same as this distance here. So you can simply take your 6 and add on 2 to get that that's 8. Now I wouldn't have thought to do that. It's a really nice method. So I thought I'd talk about it. You know, there's always these like little shortcuts, and I've definitely done this question a lot quicker than I did it originally. It's very easy to go down other paths, but we've managed it. Tough question, I think, in the end. Lots going on. Well done.